So hello and a big welcome to all of you to the second annual SAGE/GSC dissertation lecture. We are so glad that you could join us from whatever time zone you find yourselves in. The AIA Student Affairs Interest Group, or SAGE, has a tradition that we like to open every event with, and we hope you all will join us in participating. While we are not all gathered in one location, we like to spend a moment honoring the original stewards of the land that we occupy. So we encourage you all to take a moment and acknowledge the traditional caretakers of the place in which you find yourselves today. So my name is Caitlin Mccullough, and I'm a current PhD candidate in classical archaeology at the University of North Carolina at Chapel Hill. I am also one of the two outgoing co-chairs of SAGE, one of the two student groups sponsoring today's event, and I'm thrilled that after months of discussions and planning with the SCS's Graduate Student Committee, this event is finally here. So I would particularly like to thank our speaker, Amanda, and the GSC for their partnership in this event. I also want to offer particular thanks to GSC's Meredith Millar for her help in organizing over the last few months. I'll turn things over to you now, Meredith.
Thank you so much, Caitlin, for that warm welcome. I'm Meredith Millar. I'm a current PhD student in classics at New York University, and I'm a member of the Graduate Student Committee within the SES. I'm super thrilled to be back here for a second year as a co-organizer of this lecture alongside SAGE. This really wouldn't have been possible without the contribution of so many people and so many organizations, and of course, of our speaker, Amanda. This lecture series really began to take shape following the 2020 AIA SCS annual meeting, when our two student organizations recognized that there was a need for more significant and formalized opportunities within the interdisciplinary space that we both occupy. A primary commitment of both of our groups lies in uplifting and celebrating graduate research. These final stages of work on a dissertation represent an incredibly liminal space in the life of a PhD student as they release their research into the scholarly world. Our goal with this annual lecture is to provide stability and amplify exceptional work and on the cusp of its publication. None of this, of course, would have been possible without the continued support of both the AIA and SCS, who generously have provided a joint honorarium to support this lecture and to support the scholarly work of graduate students, which historically has been overlooked. The insight and assistance of these two organizations is central to the continued support of this lecture for many years to come. I'd now like to take a moment and say a few words about our two organizing student groups and to highlight additional initiatives within the broader ancient world community. I'll begin with a little bit of bias with the SES Graduate Student Committee in my capacity, of course, as a sitting member. So the Graduate Student Committee within the SES is now in its 4th year as a formal committee, and I'm happy to say, of course, is in its 2nd year of collaboration with the Student Affairs Interest Group of the AIA. I think I already illustrated for you the commitment of both groups to collaborative work, and the Graduate Student Committee is thrilled to support these moments where we can all really come together in celebration of strong graduate research. We're especially attentive to the issues within academia currently impacting graduate students and remain committed to forming strong networks of graduate students within the membership body of the SCS and beyond. If you or anyone is interested in learning more about graduate student work within the SCS, or in getting involved in connecting your department to graduate student resources, I'll be making my email available in the chat for any attendees. And with that, I'll hand it over to Amanda Chen of the Student Affairs Interest Group. Again, thank you all so much for being here. And thank you, of course, to our speaker, Amanda, for sharing your hard work.
Thanks, Meredith, for that kind introduction. A very big thank you to all those in the audience for attending this 2nd annual SAGE GSC lecture. We are thrilled this has become an annual event and are immensely grateful to the AIA and SCS for their continued support of student scholarship. My name is Amanda Chen, a second Amanda in this event today, and I recently completed my PhD at the University of Maryland. I am very proud to serve as the other co-chair of the Student Affairs Interest Group, And on behalf of SAGE, Caitlin and I would like to welcome you to this exciting lecture. And of course, thank you also to Meredith for helping to organize this event and to our speaker, Amanda. The Student Affairs Interest Group is an interest group of the Archaeological Institute of America dedicated to promoting student scholarship and concerns and is open to all. We hold annual professionalization workshops and various other events and webinars throughout the year by and for students. We invite you to follow our Instagram page, studentaffairs_AIA, as well as our Facebook page for updates. Please also check out our website, studentaffairs.aia.wordpress.com, for more information, or reach out via email at studentaffairs@gmail.com, and we'll put all this in the chat in just a second. I highly recommend joining our mailing list. That way you won't miss any announcements for summer events, and you'll be in the know about our interest group meetings at the upcoming annual meeting of the AIA and SCS. If you are interested in getting involved with SAGE, please feel free to reach out via email or reach out through our website. Thank you all again.
Okay, so before I turn it over to Meredith to introduce our lecturer, a few kind of housekeeping items. Our speaker is going to speak for about 50 minutes, after which we will open the floor to questions. If you wish to ask a question, please type it into the general chat or the Q&A chat, and we will make sure that your question gets addressed. So hand it over back to Meredith.
All right, I'm so happy to get to introduce our lecturer. So our lecturer tonight is Amanda Gaggioli, a PhD candidate in the Classics Department at Stanford University. She received her BA in Classics and Archaeology from Cornell University and holds an MA in Anthropology from Stanford. Amanda's research combines specializations in archaeology, history, and ancient languages with environmental sciences, particularly geoarchaeology and soil micromorphology, to interpret cultural forms of environmental knowledge, cultural practices, landscapes, and paleo-environments that factored into societal developments. This combined work accounts for the resilience and political ecology of socio-environmental systems in all aspects of Greco-Roman civilization. Amanda has published widely in journals and edited volumes and has delivered papers at numerous conferences, including the AIA annual meeting and the Society for American Archaeology. She also recently organized the Theoretical Archaeology Group, TAG, conference on social justice at Stanford University. Amanda has received many awards, such as a recent multi-country fellowship from the Council of American Overseas Research Centers and an early career grant from the National Geographic Society. In addition to her scholarship, Amanda has worked at a wide variety of archaeological sites in Turkey, Greece, Israel, and Cyprus, including the Gordian Archaeological Project, Eastern Boeotia Archaeological Project, and the Ashkelon excavation. It is with great excitement that we welcome Amanda this evening.
So can you hear me okay? All good? Okay, so I'll share my screen. Oh, oops, that's the wrong. Okay. So thank you very much to Caitlin, Amanda, and Meredith for extending an invitation to me to present my research for this annual dissertation lecture series on behalf of the Student Affairs Interest Group of the AIA and Graduate Student Committee of the SCS. And thanks to all who were involved in organizing this event. And thank you, of course, to those who are attending today. It is my pleasure to share my project with you, and I hope it will spark some interesting questions and discussion. The Mediterranean region, particularly the Eastern Mediterranean, is one of the most seismically active regions in the world. The convergence of Earth's major Eurasian, African, and Arabian tectonic plates, and also several platelets, complicate the types of seismicity experienced. The recurrence of earthquakes and associated seismic phenomena throughout the past have characterized the human experience of this region. However, identifying and interpreting the residues of this human-geological environment relationship in archaeology poses critical methodological and theoretical difficulties. But despite these difficulties, attempts have been made to understand these relationships in the ancient Mediterranean. Dominant discourse surrounding earthquakes and archaeology has centered on large-scale regional catastrophe or particular disaster events, more often than not of those described in one of the relatively few earthquake events described in ancient sources. The concern for earthquake factors in archaeology actually has distinct disciplinary origins on the late Bronze Age and late Roman period in the Eastern Mediterranean. These eras witnessed a societal collapse, namely the Mycenaean palaces in the Eastern Roman Empire. Archaeological evidence of widespread destructions in the Eastern Mediterranean, complemented by an inflation of historical earthquake records for the late Roman context, points to periods of higher seismicity coinciding with a weakening of economic and political structures. Recently, though, archaeological studies have begun to demonstrate how, since ancient times, cultures that lived with earthquake hazards demonstrated forms of resilience, a challenge to the catastrophe narratives. A focus on risk and resilience has become a key intervention in the study of earthquake factors on culture, politics, and economics in both ancient and modern urban settings. I will also show an alternative side of these catastrophe narratives today through the case of Helike in Greece, as this landscape of seismic and other geological hazards did not result in complete catastrophe and ending of important cultural, political, and economic circumstances which came before. Rather, Helike was an area of continuous renewal. This project answers the following questions. First, what were the human-environment relationships with respect to geological conditions and hazards, particularly earthquakes and associated seismic phenomena, and resilience in Helike, Greece from the 3rd millennium BC to 5th century CE? Second, what were the changes in these human geological environment relationships of resilience over time in Helike, Greece? And third, what was the nature of local and global structural, cultural, political, and economic development that drove or were driven by changes in human geological environment relationships of resilience in Helike, Greece? But why resilience? This project uses resilience for two reasons. First, resilience is adopted to confront the dominant catastrophe narratives of earthquakes in archaeology. Second, this investigation of Greco-Roman human geological environment relationships with respect to earthquakes employs resilience theory deductively, hypothesizing that Greco-Romans were resilient given the highly seismic environment, but that this resilience fluctuates through time. Resilience theory in archaeology uses the concept of socio-natural systems to explain human environment relationships, and particularly the role of change in cultural adaptive capabilities of learning and development through innovation and invention and innovation in facing disruptions. At the core of resilience theory is the adaptive cycle pictured here, which consists of 4 phases, including conservation, release, or disaster or social disruption, and then reorganization and exploitation. Processes and changes of socio-natural systems involve multi-scalar processes that occur in overlapping cycles, which are both rapid and gradual and also range from the local to the global. The catastrophe narratives account for the first 2 phases, but overlook the latter 2 phases in which people reorganize and exploit the materials and areas disrupted in the aftermath of a disruption. Resilience theory and the adaptive cycle offer an analytical framework for understanding the impacts of earthquakes on cultural change over the long term. Fernand Braudel calls this long-term perspective the longue durée, quote, man and his relationship to the environment, a history in which all change is slow, a history of constant repetition, ever-recurring cycles, end quote. This project adopts a long-term framework following the longue durée of Braudel, because there is no doubt that earthquake and seismic hazards recur in the same places through time. However, in archaeology, earthquakes have been viewed as disconnected, sporadic, and randomly recurring. Furthermore, the palimpsest nature of material evidence in archaeology does not permit this type of eventful history of earthquakes and their impacts on humans. This long-term approach allows us to answer the questions posed at the start, which requires comparisons between different occupation phases and different sites. This project does not adopt the strict framework of the adaptive cycle in resilience theory and archaeology, but rather uses a broad meaning of resilience and related ideas of continuity and regeneration. Resilience here means the prevention of social disruption or disaster. Taking into account definitions in disaster research and Greco-Roman earthquake narratives, which I will return to, I define an earthquake disaster as a social disruption rooted in both the seismic hazard and also the material conditions of the human-built environment that pose vulnerabilities. A social disruption results from a high death toll and or widespread destruction to the human-built environment, Destruction, since typically also the cause of death in earthquake disasters, is the root of social disruption. Therefore, resilience, the prevention of social disruption, is the prevention of destruction to the human-built environment through innovation and invention. And here, I maintain definitions of innovation and invention from resilience theory and archaeology. Inventions involve one or a few individuals, while innovations occur at the community level and materialize as a result of the spread of inventions throughout a population. I also provide a definition of an earthquake as a minimum magnitude of 5.5, since this is the level in which soft sediment deformation occurs in earthquakes, and also the level in which destruction to the human-built environment begins to occur. Although this does not imply that an earthquake always results in destruction and disaster. In the material geological record, which I will return to, an earthquake of minimum 5.5 magnitude becomes visible in this form of soft sediment deformation and destruction in the human-built environment. This slide has a lot of important definitions for the project, but the most important elements are destruction, innovation, and invention, since these are how I come to define resilience in the material geological record from Helike. So now, why Helike? Scholarship on Greco-Roman Helike is centered on the 373 BC earthquake and its disastrous effects on the political demise of Helike as leader of the Achaean League. Several Greco-Roman accounts describe the 373 earthquake disaster in Helike. The earthquake and associated tsunami and flooding brought widespread death and destruction and was remembered in terms of its causes and consequences, enmeshed in deep historical relationships between Ionians and Achaeans, and also Helike's religious affiliations with Poseidon Earthshaker. The 373 earthquake disaster remained the most famous earthquake disaster in Greco-Roman memory. Greco-Roman writers, including Emperor Marcus Aurelius in his Meditations, recalled the disaster for many centuries, often at times when earthquake disasters struck other places in the Mediterranean. Ancient Helike is located within a 15-kilometer square delta plain in the northwest Peloponnese of Greece, and one of the most seismically active regions of the world. The rapidly extending Gulf of Corinth basin and two east-west faults, the Helike and Aegeo faults, directly bound the plain. The Corinthian Gulf forms the northeastern edge of the plain, while the Carinea Mountains bound the plain on its southwestern edge, where its steep slope abruptly meets the Helike plain that gently slopes until it meets the Corinthian Gulf coast. The Salinas and Carinitas rivers bound the plain on its southeastern and northwestern edges. Interest in locating the 373 ruins began soon after the disaster. Aristotle, a near contemporary of the disaster, offered field observations on astrological phenomena, the type of soft soils, and sea currents in the region of Helike before and during the earthquake. These observations contributed to Aristotle's proposition that winds are the elemental cause of earthquakes, a predominant scientific theory on the causes of earthquakes in the Greco-Roman world. A century later, Eratosthenes visited the area and observed the clearly visible underwater ruins of Helike. The ferryman told Eratosthenes that the hippocampus from Poseidon's statue used to stick out of the water, causing trouble for fishermen. In the 2nd century CE, Pausanias observed the more corroded ruins of Helike under murky water. Based on ancient descriptions, the physical state of the ruins had changed over time. After Pausanias's descriptions, the physical location of the ruined city had been lost, but the 373 disaster remained in Greco-Roman memory for several hundred more years. In more recent history, Helike has become the site of important scientific breakthroughs in terms of both archaeological and geological discoveries. Renewed interest in the location of classical Helike began again on December 26, 1861, when an earthquake resembling that of 373 struck the Helike plain. The astronomer Friedrich Julius Schmidt visited the area to carry out a geological survey, and Schmidt traced soft sediment deformation on the surface, and also a 2-meter high and 13-kilometer long vertical scarp running east-west at the juncture between the Carinea Mountains to the south and the Helike plain to the north, what is now known as the Helike fault. His discovery and detailed recording of this scarp became important for establishing the relationship between tectonic shifts along faults and earthquakes around the turn of the 20th century. In 1861, the fault ruptured at the surface, and in the right photo, I am standing at this 1861 rupture. And being also well-versed in classical texts, Schmidt pointed out the striking similarities between the 1861 event and the Greco-Roman descriptions of the 373 event. And based on these ancient descriptions, Schmidt proposed an offshore location of classical Helike, which offered the foundations from which archaeologists would begin a rigorous search for the 373 ruins. Archaeological research in the Helike plain has centered on desires to discover the 373 ruined and submerged city as it had been described in ancient sources. In the decades following Schmidt's geological survey, several archaeologists emphasized the need for underwater investigations in the area of Schmidt's proposed offshore location of classical Helike. Before Spiridon Marinatos began his notable excavations of the prehistoric city of Akrotiri, buried by the 1630 BC Thera eruption, he devoted nearly 20 years to discovering Helike's underwater ruins. But despite these efforts, investigations led by Marinatos resulted in negative findings, not only of classical Helike, but of any past human activity or occupation. In the 1980s, a new phase of collaborative archaeological and geological research in the Helike plain began under the direction of Dora Katsanapoulou and Stephen Soter. They founded the Helicase Society that continues to lead the excavations, and the Helicase Society focused on the potential terrestrial location of classical Helike. They carried out an extensive survey of borehole drilling over 8 square kilometers, pictured here, across the Helike plain to 16-meter depths. Within 800 meters of the present coastline, no ancient cultural material was recovered, and sediments dated to only the last millennium, indicating recent deposition. However, beyond this 800 meters to the south, and at depths between 4 and 12 meters below the surface, recovery of cultural material remains spanning the Neolithic to Byzantine periods came with much surprise. An unexpected outcome of this final phase of research led by the Helicase Society was the discovery of continuous settlement from at least the 3rd millennium BC. Excavations beginning in 1995 and continuing into the present have uncovered settlement remains dating to 6 major occupation phases. These include sites belonging to the early Helladic 2 to 3 period, late Helladic 2 to 3, proto-geometric to late geometric, archaic to classical, and late classical to Hellenistic and Roman periods. Evidence of architectural destructions and destruction layers led to the identification of earthquake events at the end of 5 of the 6 occupation phases, the EH3, LH3, late geometric, classical, and late Roman. The archaic to classical period remains of a Doric temple and households have been attributed to the 373 event in particular. The interpretation of human earthquake relationships for each of these occupation phases is one of total disaster, an end of important social circumstances and developments that came before, demonstrating a parallel to the so-called catastrophe narratives of earthquakes presented at the start. The significance of Helike to understanding Greco-Roman developments on the one hand and geological processes on the other foregrounds the discoveries made in my study. I integrated ancient textual sources with soil and settlement architectural data I collected from 16 sites belonging to these 6 occupation phases, spanning the 3rd millennium BC to 5th century CE within this 15-kilometer square delta plain. While the 373 event has dominated the research agenda of archaeology and Helike, other evidences, both within the material geological record and also Greco-Roman textual accounts of the 373 event itself, point to earlier and continued earthquake factors involved in social developments from the 3rd millennium BC to 5th century CE. However, identifying and interpreting these relationships must confront critical methodological and interpretive difficulties. Earthquakes identified in material destruction have not been directly, stratigraphically correlated with geological residues of earthquakes. Therefore, earthquakes identified in material destruction must remain uncertain, and interpretations of earthquake factors with social disaster, the end of important cultural, political, and economic developments in 5 of the 6 occupation phases, must also remain uncertain. These critical difficulties in earthquake factors in the history of archaeology at Helike, though, parallel those of Mediterranean archaeology more broadly. This project uses new methods in geoarchaeology and soil micromorphology that overcome this critical difficulty in identifying and correlating earthquakes and architectural remains. These new methods include, first, an ethnography of Greco-Roman earthquake perceptions and textual sources. Second, archaeoseismology of destruction, innovation, and invention in settlement architecture. And third, soil micromorphology of seismically triggered soft sediment deformation structures. First, the methods focused on an ethnography of Greco-Roman earthquake perceptions and textual sources. rather than focusing on particular earthquake disaster events recorded in ancient sources, is characterized by the history of archaeological research at Helike and in Mediterranean archaeology in general. Ancient textual accounts of earthquakes can be read as an ethnography of Greco-Roman perceptions of earthquakes and associated seismic phenomena. Greco-Roman textual accounts of earthquakes offer forms of emic, or rather internal, culturally specific perspectives on human earthquake environment relationships. This ethnography surveyed Greco-Roman accounts of earthquakes, seismos in Greek texts, and terremotus in Latin texts, from late Bronze Age Linear B to late Roman periods, and included historical, philosophical, and literary texts. While doing this analysis, it became clear that there was a strong Greco-Roman connection between earthquakes and religion, particularly as Poseidon embodied geophysical forces and conditions and dualistic powers to both destroy and protect the human-built environment. So the project expanded to include Poseidon and his particularizing epithets, which allude to these characteristics. The project incorporated these Greco-Roman perspectives into material geological data collection and interpretation. Second, the methods focused on the archaeoseismology of destruction, innovation, and invention in settlement architecture. Archaeoseismology focuses on identifying diagnostic types of destruction and reconstruction characteristic to earthquakes, including rotated, deformed, damaged, and collapsed structural elements on the one hand, and anti-seismic reconstructions and reinforcements of structural elements on the other. I have several examples pictured here, destructions on the left and reconstructions on the right. This approach is already common to Mediterranean archaeology. The challenge, though, is accurately identifying these types with geological residues of earthquakes, which brings me to my last method, soil micromorphology. So soil micromorphology is a subfield of geoarchaeology that extends on-site studies of stratigraphy and archaeology to enhance interpretations of post-depositional processes and paleo-environmental changes on the one hand, and anthropogenic soil formation and disturbance, land management, and social uses and structuring of space on the other. It is the study of features and structures of undisturbed in situ soils in thin section at the microscopic level, using a petrographic microscope and chemical techniques. Preparation requires turning undisturbed soil block samples into petrified blocks, and then cutting these blocks into slides. Soil micromorphology uses a variety of analytical techniques, particularly the petrographic microscope, with using 3 different types of light: plane polarized, cross polarized, and oblique incidental light, to systematically evaluate microstratigraphy and soil features. This project's application of soil micromorphology to investigate seismically triggered soft sediment deformation structures is new to archaeology. Schmidt had identified and recorded soft sediment deformation on the surface in the aftermath of the 1861 earthquake. Seismically triggered soft sediment deformation structures, what I label as SSDS, occur not only on the surface, but also in stratigraphic section, and both on macro and micro scales. Seismically triggered SSDS begin to form 0.5 meter to 2 meters below the surface in an unconsolidated coarse sandy layer, capped by clay-rich and consolidated ground surfaces, as shown in this first diagram. In order for SSDS to be identified as seismically triggered, patterns and types of SSDS have to form in vertical sequence, beginning with water escape structures and then load structures. Toward the ground surface, load structures are convoluted and deformed. This is depicted in the second diagram. Therefore, the soil micromorphology investigation of seismically triggered SSDS required sampling at least 0.5 meter below, up to, and through the ancient occupation surface. This innovative application of soil micromorphology allows for an investigation of geological residues of earthquakes in the form of seismically triggered SSDS in direct association with destruction, innovation, and invention in settlement architecture. And so now I will turn to the results from these new methodological approaches to ancient accounts of earthquakes and material geological remains from Helike. The ethnography of Greco-Roman perceptions of earthquakes reveal a plurality of cultural perspectives on earthquakes in their thematic connections to not only disaster, but also religion, science, politics, human behavior, and the human-built environment. These thematic connections are persistent through time. Some of the most striking Greco-Roman earthquake narratives concern disasters in which the death toll and damage to human-built structures reached unprecedented levels, resulting in a significant social disruption or disaster. However, These experiences were rare in comparison to non-disaster earthquake scenarios. This distinction between earthquake disaster and non-disaster experiences is reminiscent of Garnsey's distinction between food shortage, a persistent risk, and famine, a rare disaster in famine and food supply in the Greco-Roman world. Garnsey exposes the important long-term risks of food shortage, which were shaped by social, economic, and political factors. Likewise, there is an important distinction to be made here in terms of scale in earthquake disaster versus non-disaster scenarios. Even though specific or accurate numbers in terms of death tolls and levels of material destruction from the ancient historical and archaeological records are lacking, the corpus of Greco-Roman earthquake narratives and textual records, including those for the 373 event, demonstrate that earthquakes were a familiar experience. However, those attributed with disaster resulting from a high death toll and widespread destruction were comparatively rare. An analysis of both earthquake disasters and non-disasters is revealing of factors of persistent geological hazards and risks on societal change over the long term, which in this case, as in Garnsey's, had been hitherto overlooked. Another conclusion drawn from this ethnography is that within the category of disaster, the 373 event was the most well-known earthquake disaster among Greco-Romans. More accounts describe this disaster than any other Greco-Roman historical earthquake disaster. But why was this the case? Why was it so famous? My argument here is that the 373 event was the most famous earthquake disaster in the Greco-Roman world, not because of the historical particularities of the event itself, but because this event embodied the plurality of Greco-Roman perceptions of earthquakes in their persistent connections to not only disaster, but also religion, science, politics, human behavior, and the human-built environment. The event, therefore, became the touchstone for Greco-Roman relationships with earthquakes. A survey of the accounts of the Helike 373 disaster, which span approximately a millennium from the time of the actual disaster in the 4th century BC to late Roman periods, reveals a number of patterns in terms of the internal cultural understandings of the socio-natural causes and consequences of earthquakes. In terms of disaster, accounts emphasize the significant death toll and widespread destruction to human-built structures, including entire cities, houses, and ships, and the resulting social disruption. In terms of religion, Greco-Romans sought divine explanation, attributing Poseidon as the cause of the earthquake and associated seismic phenomena and destruction to the human-built environment. At least from the time of Homer, the people of Helike had a special relationship to Poseidon as embodiment of geophysical forces and conditions, and also as the destroyer and protector of the human-built environment. In terms of science, accounts provide us also a scientific explanation based on geophysical observation and extrapolation of the phenomena. They observe the site-specific soil conditions and effects, conditions and the soils, soft soils prone to shaking observed at Helike supported Aristotle's proposition of winds as the elemental cause of earthquakes. In terms of political causes and consequences, the 373 disaster is also rationalized as the result of historical political disputes of the Ionians and Achaeans. As a consequence of the disaster, leadership of the 12-city Achaean League transferred from Helike to the nearby city of Aegio. In terms of human behavior, the 373 event inspired scientific and religious behaviors for the purposes of alleviating fear and anticipating and preventing disasters in the future. Immediate practical behaviors included people running from falling buildings and abandoning or resettling Helike in the aftermath. In terms of the human-built environment, accounts describe the destruction of the cities to not only Helike, but also nearby Bura and Aegiro. Furthermore, accounts observe how other nearby cities, including Aegio and Patras, did not suffer from the destruction. Accounts differentiate between the effects on public monuments versus private households and particular structural elements. Ships were destroyed, public monuments, including the temple to Poseidon, collapsed and were submerged. Private households collapsed because their foundations had been uprooted. The thematic connections between the 373 events and disaster, religion, science, politics, human behavior, and the human-built environment are representative of Greco-Roman perceptions as revealed in the survey of Greco-Roman accounts of earthquakes from the late Bronze Age Linear B texts to late Roman periods, including historical, philosophical, literary texts. This project incorporates this ethnography into material geological data collection and interpretation. Greco-Roman perceptions emphasize site-specific geological conditions. In terms of the human-built environment, Greco-Romans describe not only destructions, but also anti-seismic constructions, or rather, parts of the human-built environment that survived earthquakes. Furthermore, Greco-Romans emphasize the differences in destruction and anti-seismic constructions from the level of the city to private households versus public buildings and particular structural elements. For the archaeological investigation of earthquakes at Helike, the conclusion of rare disaster experiences in comparison to non-disaster experiences or perceptions turns the attention away from disaster events to processes. Furthermore, in terms of the material geological evidence, evidence should differ from the level of the site to public versus private buildings and to particular structural elements. Previous results linked earthquakes with the end of 5 of these 6 major occupation phases, excluding the late classical to Hellenistic occupation phase. Soil micromorphology demonstrated that all sites within the plain were constructed on fine-grained soils capping coarse-grained fluvial sediments. These conditions, combined with the construction of floor surfaces, created the overpressurized conditions of ground surfaces required for SSDS to form during earthquakes. Seismically triggered SSDS form 0.5 meter to 2 meters below and continuing up to ground surfaces in the form of water escape structures and then load structures with convoluted and deformed cross-bedding. So I'm going to focus on showing the deformation near and at the ground surface levels rather than the full 0.5 meter to 2 meter vertical sequence. At all of the sites within the plain, I discovered seismically triggered SSDS. However, they did not always occur during or at the end of occupation as previously understood. For early Helladic 2 to 3 Helike, seismically triggered SSDS are identified 0.76 meters below, up to, and through the EH3 ground surface, directly associated with the early Helladic 3 settlement architecture. Vertical formation of water escape structures with coarse sand grains originate from subterranean levels. In upper levels, they are associated with load structures, which preserve clay beds. In the uppermost levels, these load structures have convoluted and deformed clay cross-bedding. Here, seismically triggered SSDS are identified with the EH occupation and settlement architecture of the early Helladic Satis site within the plain. For late Helladic 2 to 3 Helike, seismically triggered SSDS are identified above occupation levels, but in a formation pattern similar to early Helladic 2 to 3 Helike. Here I'm showing the association of water escape structures with load structures with convoluted and deformed cross-bedding in the upper levels. The seismic trigger here occurred long after late Helladic occupation. For proto-geometric to late geometric Helike, seismically triggered SSDS are identified with within occupation levels, but associated with a later classical ground surface. And here I'm showing the initial formation of water escape structures consisting of coarse grains that originated from subterranean levels. For archaic to classical Helike, I'm showing here how the formation of seismically triggered SSDS continues upwards in the formation of water escape structures with coarse grains originating from subterranean levels, and then load structures with convoluted and deformed cross-bedding. The formation patterns of seismically triggered SSDS continue to the classical surfaces. In upper levels, the load structures have a brecciated formation in association with the continuous upward formation of water escape structures, indicating spreading of ground surface deposits. Here, an earthquake is identified with classical occupation and settlement architecture of the Mccullough archaic to classical site. For late classical to Hellenistic Helike, seismically triggered SSDS are identified 0.85 meters below, up to, and through the Hellenistic ground surface. At the late classical site, this formation, which is pictured here, the late classical site, this formation of SSDS continues above occupation deposits and post-occupational alluvium. For the Hellenistic site, the vertical formation of water escape structures with coarse sand grains originates from subterranean levels. In upper levels, water escape structures are associated with lode structures, which preserve clay beds. In the uppermost levels, these lode structures have convoluted and deformed clay crossbedding. Here, an earthquake is identified with Hellenistic occupation and settlement architecture of the Hellenistic Romanos site in particular. At the Roman road site of Helike, seismically triggered SSDS are identified over 5 meters within occupational levels. Water escape structures are associated with lode structures. Lode structures again have a brecciated formation in association with the continuous upward formation of water escape structures, indicating spreading of superficial deposits. In upper levels, lode structures have deformed crossbedding. And here the seismically triggered SSDS are identified with the Roman occupation and is directly associated with the road. However, use of the road continues after this deformation event. At the Roman Clonus site, seismically triggered SSDS are associated with a particular floor, the second of 4 floor surfaces. Previously, an earthquake had been identified with a 4th and final destruction layer at the site based on architectural remains. At all of the sites within the plain, I discovered seismically triggered SSDS. However, they did not always occur during or at the end of occupation. In addition to discovering seismically triggered SSDS, soil micromorphology results also demonstrated that the sites within the plain are prone to short-term flooding. Short-term flooding at all the sites was indicated by the formation of particular pedifeatures, including clay coatings with microlaminations of open voids, and also clay concentration features with graded bedding, indicating repeated small-scale water flow due to the constant flow of water through the plain from the surrounding Salinas and Carinitas rivers and the Caturla stream bounding the plain. In addition, at all sites located near the ancient coastline, there's evidence for seasonal and long-term flooding. Seasonal flooding is evidenced in what I have pictured here, gleeing in the formation of iron mottles with a grayish internal color, formed from the alternating reactions of organics with water and oxygen at the surface, when these were ancient surfaces. The organics were replaced by iron, but the iron replacement of organics was incomplete, causing the formation of this mottling, this alterations between this reddish and grayish color. The gleeing and iron formation of mottling indicates a fluctuating water table on these ground surfaces. Sites near the ancient coast also have evidence for long-term flooding and stratigraphically constrained microfossil remains of marine, freshwater, and brackish ostracods and foraminifera. Long-term flooding was identified in various pre-occupation phases at all sites, and also above occupation remains of the early Helladic site and classical site. This evidence is attributed to rapid coastal changes. The evidence for flooding at the sites within the plain is significant for investigating seismically triggered SSDS because water-saturated sediments amplify the formation of SSDS during earthquakes. For the sites along the ancient coasts, it can be demonstrated that the sites had higher water content due to seasonal and long-term flooding. In fact, both the 373 earthquake and the 1861 earthquake are described as occurring in winter. Seasonal and long-term flooding is also implicated in seismically triggered SSDS formation near the ancient coast, particularly in the formation of lode structures, as pictured in the example here. These lode structures with convoluted and deformed clay bedding decline in accordance with the slight slope of the plain towards the coast of the Corinthian Gulf. In addition to evidence for seismically triggered SSDS, I discovered evidence for flooding, short-term, seasonal, long-term due to the alluvial depositional setting of the plain, seasonal fluctuations in the water table, and rapid changes along the coast. The soil micromorphology investigation was carried out in direct association with settlement architecture. But how does all of this relate to destruction, innovation, and invention in the settlement architecture? On the whole, between the 6 occupation phases and 16 sites, there's a general observation of south to north oriented destructions to walls and floors, and also innovation and invention to prevent south to north destructions to walls. This is related to the south to north dipping of the Helike fault, the south to north alluvial and fluvial deposition of the plain, and south to north formation of the seismically triggered SSDS, particularly the sloping formation of lode structures near the ancient coast. East-west oriented walls have south to north offset undulations, and direction in collapse. A common innovation between the occupation phases is the incorporation of south to north oriented partitions that connect these vulnerable east-west walls. Various unique inventions are also implemented in east-west oriented walls to prevent these south to north damages. However, patterns in the evidence, while directly associated with seismically triggered SSDS or other geological hazards, are not related one-to-one with geological environmental conditions. Evidence for innovation and invention demonstrate long-term resilience in human-earthquake relationships at Helike, but the patterns reflect negotiations between not only earthquakes and geological environmental conditions, but also political leadership and organization, economic resources and production, and cultural values. What is a political ecology of human-earthquake relationships at Helike? At early Helladic 2 to 3, Helike and mainland Greece more broadly, material destruction to the public buildings for economic production and political administration would cause the greater social disruption to the proto-urban settlement with increased political and economic centralization. Therefore, the corridor houses and public buildings for surplus storage and workshop activities received the more successful invention, tripartite partitions connecting long east-west walls, and increased innovation, wider walls, patterns of innovation, wider corners, and variable inventions, north to south partitions of various types. So we have doubled walls, bipartite partition series walls, and wider partitions connecting long east-west walls in private households indicate choices influenced by greater wealth and social differentiation and resources for this type of experimentation. The east-west, rather than north-south, tripartite partition series wall of the corridor house reflects efforts to maintain the monumental form of corridor houses that required corridors on the long walls and open areas in the center. The added east-west partitions allowed the community to maintain the monumental form of the corridor house and some stability. However, as indicated by south to north undulation damage in the long east-west wall of the corridor house, the compromise between invention, innovation, and the monumental form resulted in some material destruction. The invention of the north-south tripartite partition series wall was a successful invention for prevention of social disruption to economic resources and production, as there were no north-south offset damages to these walls, but these damages are observed in private households. At late Helladic 2 to 3 Helike, unequal material destruction to the households would cause the greater social disruption to political and economic organizations centered on kinship, increased wealth, and low levels of social differentiation. Private households received uniform implementation of innovations, north-south partitions connecting long east-west walls, carvings in bedrock to form walls, and also placeholders for storage vessels. These decisions and innovation also reflect considerations of the position of Helike as a subsidiary, fortified center, or village within the broader settlement hierarchy in the palatial state of mainland late Helladic Greece, influenced by the increased wealth and interconnectedness of the palatial state, but removed from the disparities of wealth within the palatial centers themselves. At proto-geometric to late geometric Helike, unequal material destruction to private households again would cause social disruption to the increased wealth but low levels of social differentiation. However, material destruction to the public apsidal temple, the arena for political and religious activity and identity at the time, would have caused an even greater social disruption to developments in political leadership and organization, with movements toward aristocratic elites and eventually a middling class of equal citizens. Private households received uniform attention in the incorporation of innovations, north-south partitions connecting long east-west walls. The apsidal temple received increased attention in the incorporation of innovation and new invention, subsurface buttressed foundation walls of long east-west walls. This new invention served the same purpose as the early Helladic 2 to 3 tripartite partition in preventing south to north damages. The implementation of this new invention in the apsidal temple reflects important considerations given to the state of political leadership and organization and cultural values and identities centered on public religious architecture. Structural choices in the east-west oriented walls of the apsidal temple could have included partition walls, as in most other cases, rather than this new invention and more labor-intensive subsurface foundations, but internal partitions connecting long east-west walls would disrupt the monumental form that required a central row of columns on bases running parallel to the long walls from the entrance to the apse. New invention in subsurface foundation and retention walls allowed locals to maintain both the monumental form of the apsidal temple and stability of these structural elements. Although, as circled here on this slide, the walls still have some south to north bending in these long east-west vulnerable walls. At Archaeological to classical Helike, like the preceding occupation phases, unequal material destruction to private households would cause social disruption to continually increasing wealth and low levels of social differentiation. However, material destruction to the public Doric temple, the arena for political and religious identity, not only for Helike, but in this period also for the Achaean League, would have caused an even greater social disruption to developments in political leadership and organization centered on a middling class of equal citizens, and also Helike's leading status of the Achaean League. Private households received uniform attention and innovation, north-south partitions connecting long east-west walls. However, due to limited excavations, comparisons with invention and innovation in the public Doric temple are not possible, but it is hypothesized that excavations will uncover more innovation and perhaps even new invention in the Doric temple that reflect this growth of the city-state, centered on the political leadership of a middling class of equal citizens, and a religious and political identity attached to Helike's patron deity, Poseidon Earthshaker. As this the site of the Doric temple, the Mccullough site, has evidence for historical and symbolic associations with Poseidon, at least beginning in the geometric period. At late classical to Hellenistic Helike, unequal material destruction to private households, again, would cause social disruption to the wealth and low levels of social differentiation that continued into the late classical period. However, material destruction to the public textile production building complex would have caused an even greater disruption to developments in the growing emphasis on economic resources and production over political leadership and organization in Hellenistic Greece. Private households received uniform attention and innovation, while the textile production building complex pictured here received increased attention in the incorporation of innovation, so wider walls, north-south partitions connecting long east-west walls, and invention, subsurface placement of tanks, and subsurface placement of storage vessels, and iron clamp repairs. The inventions of iron clamps repairing pithoi storage jars were damaged from ground surface deformation. These repairs represent short-term and reactive rather than an intrinsic part of the long-term planning and experimentally tested and planned solutions in this human-built environment. At Roman Helike, material destruction of the private elite villa and public road would both cause social disruption to a growing emphasis on economic resources and production. Both the wealthy household, the Roman villa, and the Roman road, the infrastructure, received attention in the incorporation of new inventions, buttressed subsurface foundation walls of east-west long walls in the elite villa, and exterior supporting walls in the east-west public road, both in the overall planning and in repairs of maintenance. These inventions serve the same purpose as proto-geometric to late geometric subsurface buttress foundations and the early Helladic 2 to 3 tripartite partition series walls in preventing north-south oriented damages. Invention in the subsurface buttress foundation walls incorporated into the overall planning of the private elite villa similarly indicates consideration given to economic functions, since the villa served not only private living, but also large-scale agricultural and textile production activities. Structural choices in the walls of the private elite villa could have included more partition walls connecting east-west walls, as in lower class households, rather than the more labor-intensive subsurface buttress foundations. However, internal partitions connecting the walls again would disrupt the large open spaces, contributing both to the economic functions of the villa and also to the monumentality of the villa. Disrupting this form would inhibit both economic resources and production and expression of high wealth and status. The lack of damage to the Roman road, despite associated evidence of seismically triggered SSDS, demonstrates the capacity of the overarching political leadership and organization to repair and even improve infrastructure in facing earthquakes and other geological hazards. While evidence is lacking, it is hypothesized that the masses of lower classes lack similar resources and capacity for implementing invention and innovation in private households due to the greater social differentiation and wealth disparities in Roman Greece. The combined material geological evidence from Helike from the 3rd millennium BC to 5th century CE, informed by Greco-Roman perceptions of earthquakes, answers the questions set out at the beginning. The material geological evidence of seismically triggered SSDS and innovation and invention in the human-built environment serve to prevent social disruption or disaster from earthquakes and other geological hazards. Innovation and invention, i.e. resilience, changed over time. This change in resilience in the implementation of innovation and invention points to a political ecology of human earthquake relationships at Helike. Political ecology has many orientations in the fields of anthropology and geography. Some stress political economy and power, while others more formal political institutions. Some emphasize environmental change or local environmental knowledge and intervene in environmental activism and justice, while others focus on critiquing science and modernist assumptions of human nature binaries. But here I focus on two definitions. First, I focus on what Bierzak identifies, quote, political ecology today more generally abandons the dualisms of the past and the reductions that binaristic thinking encouraged and focuses instead on the interchanges between nature and culture, the symbolic and the material, and the local and the global, end quote. Second, I focus on Forth's definition, quote, the social and political conditions surrounding the cause, consequences, experiences, and management of environmental problems, end quote. So following these definitions of Bierzak and Forsyth, political ecology explains human environment conditions and change through a focus on local, global articulations of politics and power and hybrid socio-environments through both innovative natural sciences and also the incorporation of cultural logics in material and symbolic life. By global, I am referring to the broader cultural history of mainland Greece and the place of Helike within these broader political, economic, and cultural structures. This project incorporated cultural logics from the ethnography of Greco-Roman earthquake perceptions. Results confirm that material geological evidence would differ from the level of the settlement to public versus private buildings and to particular structural elements. In terms of innovative natural sciences, the results for the 6 occupation phases of Helike demonstrate for the first time a new application of soil micromorphology and archaeology to successfully investigate seismically triggered SSDS, addressing critical methodological difficulties and directly linking architectural remains with geological residues of earthquakes in the archaeological record. Furthermore, it was demonstrated that seismically triggered SSDS were co-produced. Constructed surfaces contributed to the compactous surface capping unconsolidated coarse-grained host deposits required for seismically triggered SSDS to form. The new methods, informed by Greco-Roman perceptions of earthquakes, led to new discoveries in how broader political leadership and organization, economic resources and production, and cultural values are implicated in resilience, the prevention of social disruption or disaster, through innovation and invention. Through time, anti-seismic invention and innovation is persistently emphasized in centers for political leadership and organization, economic resources and production, and cultural values. However, with changing political economic structures and cultural values, the emphasis of public and private buildings changes, and therefore strategies in preventing social disruption due to destruction in the human-built environment through innovation and invention also changed through time. In expanding traditional methods and evidence at the classicists' and archaeologists' disposal, Greco-Roman history and archaeology gains new light. In this case, proving catastrophe narratives of earthquakes to be either too false or too simple. Methodological advancements in geoarchaeology and soil micromorphology applied to Helike establishes new hypotheses, methods, and data sets that reveal resilience in political ecology, uncovering a hitherto overlooked history of the relationship between geological processes, particularly earthquakes and associated seismic phenomena, and societal development and change in Greco-Roman society and culture. In the future, I think studies should continue to apply interdisciplinary methods and assert the processes and plurality of perceptions and experiences in investigating human geological environment relationships in the Greco-Roman world. And at this point, well, I would like to acknowledge all of these people and institutes that supported much of this work. And at this point, I'd be delighted to answer any questions.
Thank you so much, Amanda, for that really fantastic and quite rich presentation. As Amanda just mentioned, we would be very happy to take any questions from the audience at this point. And we ask that you type any questions you have into the Q&A. So I guess we'll give it a second for people to gather their thoughts.
So one thing I'm kind of wondering, while we're in kind of the meantime of people getting questions ready, so how do you kind of differentiate when you're thinking about structural changes to some of these buildings? How do you differentiate between structural changes that might have been implemented for social reasons or for additional reasons other than earthquake or seismic activity initiated kind of events?
That's a great question. And I think it's actually, the answer is like a non-answer, in that concluding political ecology is saying that it's not necessarily, the implementation of a structural element can involve it can involve environmental perception, it can involve cultural values, it can include different social reasons for implementing a particular element. And so I don't necessarily want to differentiate between the two. I think the greater point is that I'm establishing the association between the two, and a fairly strong association given lots of evidence across different sites and occupation phases. But even still, despite all of these associations, there's still social choices involved and political constraints, cultural constraints, in how innovation and invention is applied.
Looks like we've got one of our first questions here in the chat. I'll go ahead and kind of read this one out here. So could you comment on how your talk and its results parallels the other big environmental danger in the Mediterranean, namely volcanism?
Oh, that's a great question. I think that, so in much of what I did with the ethnography, a lot of it actually included some volcanism. I think for volcanism, it could be a similar type of scenario of political ecology, but innovation and invention is going to be very different, and something that might be useful to look at when investigating something like a political ecology of volcanism in the Greco-Roman world or anywhere. Would be thinking about settlement, how people settle. I think that rather than maybe looking at particular structural elements, but thinking about how people strategize settlement, because different risk factors would be involved. But I think there would be a similar relationship between volcanic disasters versus just the experiences of being around a volcano. You know, I think a volcano is much more prominent in the landscape, and so there would be a similar relationship between disaster volcanoes versus just different types of cultural experiences with volcanoes that have nothing to do with experiencing a disaster. So I think you would find similar relationships, but the material evidence would be different.
Kind of building off of that question, Amanda, specifically with regards to volcanism, we see in numerous ancient sources that do account for volcanic eruption, of course, thinking Vesuvius here, that there are also noticeable records of earthquakes surrounding eruption. Like earthquakes are an element of the experience of an eruption. So do you think that these two types of environmental disasters end up linked for people, or because of the seismic nature of the region and the fact that Helike is, you know, earthquake without magma spewing everywhere, that in ancient perception, that there is kind of a differentiated sense there?
Yeah, that's a great question. And I think that, yeah, the volcanoes and earthquakes are definitely interrelated. And prior to using a method like the way I'm using soil micromorphology, other archaeological cases that are the best for this are those with volcanic eruptions that are preserving remains, where you know that earthquakes were happening at a higher magnitude years and months prior, because you see in a more immediate sense how people were interacting with these hazards. But in terms of people's perceptions being in a volcanic environment, certainly they had, I think they might have even had a more immediate perception of earthquake hazards, just because they would have likely experienced them more. So certainly yes. For Helike, without volcanic eruptions, high magnitude earthquakes tend to recur still pretty free. I chose Helike as a case because earthquakes recur, and high magnitude earthquakes recur more frequently than in most other places. So it would have been a part of the lived experience. Like, you would have experienced at least one in your lifetime. That's the estimate I come up with. But in a place with volcanic eruptions, certainly earthquakes, there would have been, yeah, a more immediate perception of earthquake hazards. And this is evidenced in these cases like Pompeii, and also the Thera eruption, even though we don't have textual records. But those, like the distinctions I make in the human-built environment, public, private versus, or citywide, private versus public versus structural elements. If you go look at the accounts of like the 62 CE earthquake prior to the eruption, you see all those same relationships really come out of those texts. Those texts are part of my ethnography that I look at. So.
And do you, this is related, but do you find your area of research informed by the fact that you've been doing this work while a student at Stanford in the Bay Area, and presumably earthquake perception and experience is that's a lived experience you also are bringing to the table?
Yeah, certainly. So I came to Stanford knowing I was interested in earthquakes. So that was definitely an appeal. And at Stanford, we have, I've taken classes with engineers who are thinking about, we kind of like filled each other's role. Like they wanted to know the social aspects of disaster, whereas I was like, I want to know how like engineers are approaching disaster. And that has certainly informed my work. And there's like a Stanford Urban Resilience Initiative within the earthquake engineering on campus. And so it certainly has influenced my my thinking and my research. And likewise, I think it's also influenced how they are thinking through, resilient approaches to mitigating disaster. So certainly it's had an effect.
It looks like we have a question in the chat. How did they transfer the knowledge and inventions over multiple generations without a destructive event?
That's a great question too. So it would be likely that generations, for the specific case of Helike, that they would experience a destructive event in their lifetime. But even if they didn't, the mechanism that I think is at work here is just a building culture that becomes subconscious over time. It just becomes a way of a building way of doing things. So something across the different occupation phases is the connections in vulnerable long east-west walls. And when someone builds a building with a north-south partition connecting these vulnerable walls, it doesn't have to be an immediate response to any type of earthquake, but it's become a part of the building culture and a part of the cultural memory. And something that has come out of the ethnography is just that the cultural memory of environmental phenomena is incredibly long in Greco-Roman accounts. They remember events beyond generations. So part of it is cultural memory, part of it is direct experience, even if it's not a destructive event. Part of it too is just overarching, in terms of how it's implemented, I think it's an overarching political, the overarching political structures and how they're implemented. And I'll just say, I mean, because we were talking about the Bay Area before and how that's influenced. Like if you look at any building that's built today, the seismic environment is taken into account of that building, even though we haven't experienced a destructive event for 50 years, basically here.
Looks like we have another question in the Q&A. Descriptions of earthquakes during the Imperial period can often be rather brief or focus on relief efforts following events rather than details of the earthquake itself, presumably to avoid pretentious connections between the disaster and the legitimacy of the current imperial dynasty. To what extent does this politically skew our perception of the Helike and Burra's significance in ancient thought? I'm thinking here about the Lydia earthquake, which Pliny describes as, quote, the greatest in human memory, end quote, but has only half the references in comparison to Helike.
Well, in terms of the first part with the imperial, where there's more of an emphasis on emperors giving tax relief, I think this was a political strategy to kind of weave away responsibility from the randomness of earthquakes. It becomes a part of this political relationship and political benefactions through time. And how does this skew our perception of Helike and the significance? I don't necessarily know how the first part of this question would skew the perception. Maybe Maxwell would be able to expand on how, like maybe Maxwell could speak and say why he thinks that would skew the significance of that part of Helike. But in terms of the Lydia earthquake being described as the greatest in human memory, there are several earthquakes described as the greatest in human memory, including the 373 earthquake. But I see what you're saying. So how would Helike, okay, so if there's a new earthquake, I'm just trying to understand the question a little bit better. Yeah, I guess I'm sorry, I just don't understand.
I'm not sure we have the audio capabilities for them to kind of reply right away. So maybe they can expand on that a little bit in the chat, possibly.
Yeah. And I think while we wait for clarification from Maxwell on that point, there is another question in the chat. Do you see any distinct advantages to the earthquake? For example, coastal progradation.
Let me read that question. Do you see any distinct advantages to the earthquake? Oh, yeah. So yes, the plain, because it's rapidly, it's every year, it extends, it propagates every year. It's really a rapidly forming plain. And this is balanced out by these, I don't want to say it happens in cycles, because I'm not trying to say that environmental phenomena happen in cycles, but when these big earthquakes happen, it causes the coast to kind of shrink again, it compacts the coast, and that's where you see the coastal change. But in terms of the advantages, yeah, it's these rich alluvial soils are great for agriculture. And even today, all of it is like agricultural fields, like fruit trees. And in my soil study, there's a lot of plant remains, but with the dissertation, I was focusing on a particular type of question. And so I think there is a lot to also look at in terms of the agricultural richness of the plain and how that relates to balancing like geological, like environmental hazards with environmental like benefits to this really rich plain. That's a great question. And the archaeological evidence points to this agricultural richness too, because there's lots of storage pithoi, lots of evidence for agricultural production and surplus agricultural production.
Oh, it looks like Maxwell has expanded here. So no worries about typing fast, Maxwell. So he says, I meant skewing in terms of the number of references we have, making Helike to seem more important in ancient thought because more authors may speak on it without fears of political repercussions. But he thanks you for your answer so far. As this one is
oh, yeah. Yeah, okay, I see what you're saying now. So there would be political repercussions for describing how terrible an event is because the emperor has some responsibility for taking care of the event. So I think that's a really great question. And that actually isn't something I've thought about, but definitely something to think about in the future is how disasters are spoken about. And I'll just say that too, Pliny describes that Lydia earthquake. He also describes the Helike earthquake too. I can't remember if he in particular says it's the worst to have ever occurred in Greece or not. I can't remember in particular, but he does talk about both.
So Amanda, I think one of the really exciting contributions of your project is the true interdisciplinary nature of what you're doing. I know you mentioned that your project is one of the first instances of bringing soil micromorphology into the archaeological sphere. And I was just wondering if you could talk a little bit about your process and how you brought together all of these different kinds of materials and methodologies to bear on your research.
That's a great question. And I'll just say, first of all, that soil microbiology is used in archaeology. It's just the way that I'm using it to study earthquakes is new. So I'll just say that just because I don't want to belittle all the people who do really fantastic soil microbiology work in archaeology. But in terms of how I, came to all these materials, it was really just a terrible, and I don't know if it's terrible is the right word, but curious obsession with this question of earthquakes. Working in the Eastern Mediterranean, a lot of us work in the Eastern Mediterranean, or just the Mediterranean in general. Reading archaeological reports, you come across earthquakes all the time, but they're passively mentioned. Obviously, they happen in places, but it's really hard to interpret them. And so it's really become a methodological issue. I almost abandoned the question because I just thought that there was no a good method to look at it in the archaeological record, but still thinking it's a really important question to explore. So the way I came to all the materials, one is that these are the skills I have. So I can read ancient texts, I can do archaeology, I can do archaeological science. And when you have a research question, for me, it makes most sense to answer the research question with all of the methods and data at your disposal. So it's really a matter of just answering the question as best as I can. And being obsessed with this question, I needed a new method to do it. So that's how the method came. I started doing soil micromorphology, though not to do earthquakes. I was just doing it because I am more generally interested in human environment relationships, and soil micromorphology seemed like a good method for that type of question. And then I started looking at earthquake archaeology in Japan and was seeing how they look at sediments because they don't have architecture preserved like they do in the Mediterranean. So I started to get this idea that you can use soil micromorphology in this way. And then there's a lot of paleoseismology literature on soft sediment deformation. So there is a lot of literature on it, just not applied to archaeology. So, yeah.
All right. Well, if there are no last minute questions coming in, I want to offer one last round of virtual applause or otherwise for our speaker. So thank you again to the AIA and the SES for their support of this event, including the technical support on this Zoom. Thank you, Christina. Thank you again, Amanda. It's been kind of fantastic to hear about your project. And thanks to you all for coming and joining us today. We hope to see you again at the annual meeting or in one of our virtual events.
Yeah. Thank you very much for having me. This was really great. Thank you.
Right.